The manager of a hotel finds guests spend a mean of 12.5. Well, let's just do a sketch instead of just writing the variables out. We've got our mean of 12.5. Standard deviation 2.8. And we're asked the percentage who shower for more than 13 minutes, greater than 13. So we're looking for the tail. Put your 13 on and just identify we're looking for this tail in here. So we're testing 13 against 12.5 divided by the standard deviation of 2.8. Gives me a small number here, 0.1786. So I go to 0.17 and 0.1. Well, let's look at it this way. I'm at 0.17 and I'm 86% of the way to 0.18. So why don't I look at 7 and 8? And we get 86% of the way there. So it's going to be a small number anyway, because these are so small. So I've got 0.175675 and 0.08 is 5714. That's a jump of 2075 up to 14, 39 by 86% gives me 33.54. So I'll round up to 34. So I'm going to jump 34 from 75. So 25 and 9 would be 5709 is the best value we can get for 0.1786. So the other side of that is 42.99, 90, 42.91 would be greater than 13 and less than 13. The hotel has installed a hot water system, can provide enough hot water for 100 guests. Find the probability, well, provided the mean shower time for the 100 guests is less than 13 minutes. So it's the same value again, we're testing the 13. So find the probability there will not be enough hot water on a morning that the hotel has 100 guests. So they're bringing in this sample of 100 here. Let's test these 100, imagining they all came on the same day. So that 2.8 on the bottom is going to become 2.8 over the square root of 100, which I can see will be able to be simplified quite easily, 0.28. So instead of dividing by 2.8, we're testing the same number. We're dividing by 0.28, which is going to change 0.1786 by a factor of 10 to 1.786. So now we're going to need to look up a z-score of 1.7. If I look up the 8 part, and then we are 60% of the way to the 9th part, 1.78, 9625 and 0.9633. It's only a jump of 5 and 3, 8. 60% of 8 is 4.8. So if we jump 5, we'll get to 9630. So that is the probability of it being to the left hand side of 13. So the probability of greater than 13, which would mean there will not be enough hot water, is 1 minus that. We're going to have 3.7, 0.037 or a 3.7% chance of there not being enough hot water. Question 7. A normal distribution has a mean of 80, standard deviation 8. Look for n in this case. So what do they give us? Mean of 80, standard deviation of 8, sample size of n, and the mean. We're testing x bar is the mean of the sample. So we want to see what we have first to start with. When we have this 1.1977 is telling us that the probability that x hat is greater than 82 is going to be a tail that's worth, this tail here, 0.1977. So the reverse of it is going to be 0.8023. So whatever this score is 8023. When we go to our z-score table, we find 8023 under 0.85. So 0.85 is my z-score, and this enables me then to find n. So I can say that 82 minus 80 divided by 8 over the square root of n has to be equal to 0.85. 2 over 8 is 1 over 4. This 2 over 8, 1 over 4. So we're going to get 4 over square root n equals 0.85. No, we're going to get 2 over 4. We're going to get root n over 4. We're going to get root 2 and root n. Root n goes on top root n over 4. So we're going to get root n to be 3.2 and 2, 3.4. Square both sides. 3.4 squared is 11.56. And with n, we need the nearest whole number going up. So n, in this case, is not 13, it's 12.